I'm Anil Kumar. Welcome to my YouTube channel and the website. We'll discuss a test paper on vectors in this particular video. We are taking questions related to application of forces and tension. In case you want to learn from me, you can always send an email on the address given. Let us now enjoy the concepts and learning with the student Akshit. Hi Akshit, how are you doing?
Hi, sir. I'm doing great. How are you?
Very good, very good. So today, what do you want to learn?
Sir, today I was hoping we can discuss forces as vectors.
Forces and vectors. Okay. So what I will do is I'll just share with you a whiteboard,
Okay.
and then we'll go through some questions.
Yeah.
I'm going to take questions from my YouTube videos, right? Well, we'll see how do we solve them. Okay. So we're talking about vectors, and the application is force. Rather, we'll consider many forces acting at a point.
Yeah.
So when a force acts at a point, it will make that point move. If multiple forces are acting at a point, we might have something which is called a resultant force.
Yeah.
And so the questions are related to kind of work done at many times. If it is an inclined plane, in that case, we could have the force which could make the body on the inclined plane stay there. I mean, not
Yeah.
to move, right? So the type of examples which we are going to consider today will be, let us say we have a couple of forces acting at a particle. In that case, what is the resultant force, right? So
Yeah.
that could be one kind of question. Then we will also consider the questions where we'll talk about inclined plane, where let us say there is some object and we're looking into the force which will keep it at the same place. Well,
Yeah.
we can have cases where friction is included or not included. However, to be very simple, we'll exclude friction for time being.
Okay.
We could also have a situation where we may, on a body, apply a force and see what is the component of this force which makes it move, right?
Yeah.
So that could be the case. And the most important case is when we're talking about something which is hanging. So in that case, let's say we have something, maybe a fan hanging or a light hanging, and these are the two strings which are used for that particle to be hanging. And we are given these angles, and we know what is the weight here, right?
Yeah.
So in this case, we'll look into the force diagrams, right? So what are the resultant forces and all those things. So we are actually going to look into all these four situations with the help of examples. And these examples, which I'm going to take, are from previous test papers.
Yeah.
So once you know how to tackle these examples, you are actually better off. Okay, so let's begin with one of the types of these examples. Let me clear the screen. And let us now consider that there are two forces acting at a particle. Let's say this is one. Whenever you want to draw forces, try to draw one as the horizontal force. It helps. You get the
Okay.
idea.
Yeah.
So let us say there are two forces, and we have the magnitude of the force is given to us as, let's say, 3 newtons
Yeah.
and 4 newtons. We also know what is the angle between them. And if the angle is, let's say, 35 degrees
Yeah.
between these two forces acting at a point P, in that case, you have to find the resultant force. Can you tell
Yeah.
me what is going to be the resultant force?
Yes, sir. So we can use the parallelogram law to transfer the vector 4 newtons to the other side and then draw a resultant.
Perfect. So we'll place this 4 Newton force with the tail at the head of or the tip of 3 Newton force. And we do, as you're saying, a parallelogram. So the forces are vectors, which can be displaced and placed anywhere. Their magnitude and direction are the two important things. If you maintain that this angle still with horizontal is 35 degrees, in that case, it is exactly the same force, correct? And therefore, we can now say, what is the resultant force? The resultant force in this particular case will be from P to, let me complete the parallelogram, right?
Yeah.
And there you go. Right? So that becomes the resultant force. Right? Now tell me, in this case, what is the value of R?
Yes, sir. So to find the value of R, you must know the angle in the right between, right? So we can do 180 minus 35 for that to get 145. And then use cosine law.
And cosine law. So R squared will be 3 square plus 4 square minus 2 times 3 times 4 times cos of 180 minus 35 degrees, correct?
Correct.
Or you can say R is equals to 9 plus 16 minus that 180 minus 35 becomes minus cos. Do you understand?
Yeah.
It will be plus 6 times 4, 24 cos of 35 degrees. Do you see that?
Yes, sir.
Square root. So now you can use the calculator and calculate the value. You get the idea?
Yes, sir.
Can you tell me what do you get?
Yeah, I just did it. I get approximately 6.68 newtons.
6.68. 68 newtons. Okay. So you found the resultant force R. Now, whenever you find resultant force, you have only the magnitude now, right? You have to now find the angle.
Right.
So tell me, what is the angle which it makes with 3 Newton force?
So, sir, we can use sine law now, right?
We can use sine law. So what will be the angle? We can say sine theta over the side opposite to is 4 newtons, right?
4 newtons. Yeah.
Is equal to sine of 180 minus 135, right?
Yeah.
180 minus 35 over resultant 6.6. When you calculate it, it is good practice to write 4 decimal places. You get the idea?
Yeah.
Right. Not the rounded figure, right? So I will say 4 decimal places, okay? And then you find what angle theta is, right? So how much you get? Theta equals to sine inverse of 4 over 6.68. I want you to take it to 4 decimal places. Sine of, you're saying 145 degrees, correct?
Correct.
What do you get?
So theta is roughly 20.1 degrees.
Okay. So when you write down your answer, you have to say what is the resultant force. You say resultant force is a vector, and therefore resultant is with a magnitude of 6.68 newtons, making angle 20.1 degrees with 3 Newton force. Do you see that?
So, sir, in this case, 3 newtons, the vector 3 newtons is our reference point in that way, right?
In a way, the way we have drawn, right? So, and we found this angle theta with reference to 3 newtons. So you have to mention from where, right?
Right.
So that completes our very first question. So I hope it makes sense, right? Let me now pick up another question for you. Let's say question number 2. I'm going to select this from past test papers. Let's clear the screen, right? So the question number 2 is, we are given different forces, okay, acting at a point. So which of the following system of forces cannot be in a state of equilibrium? So the question here is, which of the following system of forces? The many forces are acting.
Yeah.
in the state of equilibrium. Okay, so there are 4 options for you. First is we have got 12 Newton, all are acting at a point, 10 Newton and 6 Newton. Option B, let's say A and B. Right? A, option B is 13, 15, and 29. Option C is 1, 2, and 3 Newton. And option D is 1, 1, and 1 Newton. So which one will that system will not be in equilibrium? What do you understand from this question? Can you elaborate? What does it mean?
Yes, sir. So initially, when the question states which of the following cannot be in equilibrium, right? What I first consider is that when the system is in equilibrium, right,
Yeah.
then all of the forces must result in 0, right? That's what the
Okay.
equilibrium.
Mhm.
So, I think I'd try to approach this problem by seeing that which of these like systems would be equal to 0 if they were like subtracted or added together.
Mhm.
But sir, I have a quick question.
Yeah, yeah.
Because if we do what I just said, right, none of them are equal
None
to
of
0.
them.
So
So your logic is not quite right, because let us say, even in the last case, right? So in the last
yeah,
case, we had 3 Newton, correct?
right,
We had 4 Newton, correct?
correct.
And if I apply reverse direction, that's 6 point whatever we got answer, right? 6.68.
Yeah.
In that case, because I am applying equal and opposite force to a resultant force, the particle will be at equilibrium. You get the idea?
Oh, okay. Yeah.
However, their sum is not 0, whatever you are saying, correct? Because
Correct. Correct. Yeah.
it is the component cos theta or sine theta, which you should net result into 0 if you split them into x and y components, right?
Right. Right.
So that is the whole thing. And therefore, it doesn't really work out, right? Or,
Yeah.
so now important thing here is, let us also consider how we did it. So in this particular first example, what we did was that we translated this 4 newtons here, right? And we were saying that is the resultant. Is it okay? We formed a triangle. If that resultant, if we have an equilibrium, then this we have to apply a force equal and opposite to this resultant. Do you see this?
Yeah.
So the net result is that we have two forces, 3 and 4 newtons, but the third force is equal and opposite to the resultant. So we form a triangle. And since
Yeah.
that triangle is formed, you start from here, go 1, 2, and come back to the same place. That means
Oh, okay.
you are at equilibrium. Do you see that process?
Right. Yeah.
So what happens is that when you're looking at equilibrium, then in that case, you're definitely applying the third force, which is equal and opposite to the resultant force.
Right.
Then the system is in equilibrium. That really means that you are forming a triangle, right?
Right. Right.
Because only in a triangle, starting point, you go and come back to the starting point. That is the equilibrium.
Yeah.
So now we have to use the properties of triangle. The most important property of triangle, which helps us answer this question, is that sum of two sides is always greater than or equal to the third side. It could be
Right.
equal to if they're in a straight line. You see that?
Yeah.
But definitely, the sum of two sides cannot be less than the third side.
Less than the third side. Right.
So this is the property which you have to use to answer this question. Now, can you answer which one is the right answer? Which will not lead to a triangle.
Sir, I think it's B, right?
Correct. Because sum of 15 and 13 is 28, which
Right.
is smaller than 29. So that will not form a triangle. And therefore,
Correct.
it will not be in equilibrium, correct? It cannot be in equilibrium, right? That is the whole concept. So is this part clear to you?
Yes, sir. Just a one clarification.
Yeah,
So
yeah.
basically, what equilibrium basically means is that what we need to do in order to complete the triangle, right?
Yes, yes.
Okay. Yeah.
So 1 Newton, 1 Newton, 1 Newton makes a triangle, equilateral triangle. You see that?
Yeah, equilateral triangle, exactly.
Now, we also have sometimes a question is that equilateral triangle is formed with three forces and it is in equilibrium. What is the
Yeah.
angle between the two forces? Tell me.
Okay, so would you to calculate the angle between the two forces, right? If you split the triangle in half, then can you do it like that?
Okay, so basically what you see is if you see angle between F1 and F2, right? Do you see
Yeah.
that angle is how much? You have to put tail to tail to get the angle. Do you see that?
Oh, okay.
So many times students will say 60 degrees. Why it is 120 degrees in this case? Do you see that?
Yeah. Yeah.
You get the idea. So
Yes,
when
sir.
we talk about angle, look at it very carefully. Force is F1 in this direction, correct?
Correct.
So F2 is in this direction. And F3 is in this direction for the particle P to be at equilibrium, correct?
Correct.
Now, what is the angle between F1 and F2? You have to put the tails together. So you get the angle of 120 degrees,
120
not
degrees.
60 degrees, not 60 degrees. You get the idea.
Yeah.
So this another
Okay.
question based on this concept is that we have a system which is at equilibrium with forces of 1 Newton, 1 Newton, and 1 Newton.
Yeah.
Find the angle between the two forces, F1 and F2, for example.
Right.
So obviously, when you look at it, you say, oh, it's an equilateral triangle, means 60 degrees. Don't jump to the conclusion. This is what I'm telling you.
Right.
The angle between these two forces is actually this angle, right?
Right.
So
Yeah.
be careful on this part. So that's another test question for you. Okay.
Yes, sir. So for this part, we just moved the F1 vector. We just like displaced it to the right, right? To
Yes.
form another. Okay.
To find angle between any two vectors, you have to put them tails together.
Tails together, right?
Here also, if you see, to put tails together, this is the force, right? This is going up, right?
Yeah.
Correct. And so this angle will be 120 degrees.
So everything would be 120 in this case. Right?
Yeah, because that is 60 degrees. Do you see that? 180 minus 60 is 120.
Right.
So that's very important to understand. Okay. So
yes, sir.
Another very important question we have just discussed, right? Now, as you were saying, many times when we act on work on forces, you have to split a force into its vertical and horizontal components, and you could actually solve many questions. Even the first question, which was on resultant force, with the help of vertical and horizontal forces, right? So let me take that example once again. Question number 1, where we had one force F1, which was, we said, 3 newtons, right?
3 newtons. Yeah.
And the other force, we said F2,
4 newtons.
which is 4 newtons, right? And the angle between them was 35 degrees, correct?
Yes, sir.
Now, let us try to find resultant by resolving the forces into two components, right? So let us say we have drawn them purposely, one of them along the x-axis. Is it okay?
Okay.
Now, if I resolve F1 into x and y component, I could say that F1 is basically equal to 3 along I. I is my component along x-axis. Okay.
And 0j, right?
And 0j. And that's my vector F1.
Yeah.
For F2, what is my x component?
Sir, your x component, you would have to do cos theta, right? Cos 30 times 4?
Yeah, because the angle is 35. So cos of 35 times 4. And the y component is 4 sine theta. Right? Is that okay?
Yeah.
So these are my two forces. Now, when I am saying resultant, I'm basically adding these forces. Is that okay? So let's call that resultant force. So when you add them, what do you get? The I component is 3 plus 4, cos of 35.
Cos of 35.
And the y component is 4, sine of 35 degrees. Do you get the idea?
Oh, okay. Yeah.
Now that directly gives you the angle also between I and j, because see, tan theta will be what? Tan theta is the I and j component.
I over j, right.
Right? Do you get the angle theta? You get the idea?
Yeah.
So let us now calculate. Please calculate. What is 3 plus
Yes, sir.
4 cos sine 35? Let's write down. 3 plus 4 cos 35 degrees.
So 3 plus 4 cos 35 is 6.27.
And what is 4 sine 35 degrees?
2.3.
2.3 j, correct? Now,
Yeah.
that is the vector. This is the vector r, which we had been talking about. Do you see that?
Yeah.
Without making a parallelogram or a triangle, we actually resolve the force into two components along
Right.
x and y axis, and we got the resultant. This is a very beautiful method of
Yeah.
finding the resultant in many cases. Now, what is the magnitude of this force? Can you please calculate a square plus b square square root?
Yes, sir. I can do that. So it would be 6.68.
Same answer you got, right?
Yeah, same answer.
6.68. You see how? And since we know that I and j components are given to us, what is tan theta?
So it would
Tan
be
theta will
y
be,
over j, right?
yeah. So the j component is the sine component, right?
Oh,
So
sorry. Yeah, yeah.
2.3 over
G over.
6.27, right? Theta is
Yeah.
tan inverse of this. Find out. So theta equals to tan inverse.
So it would be 20.1.
You see that? 20.1
Yeah.
degrees. Same answer. What I'm trying to say here is that there are three ways of solving systems of equations.
Yeah.
One, you could make a triangle. Second, you could make a parallelogram. Now, those
Right.
first two methods, triangle and parallelogram, really works if you have only two forces. I mean, if it is more than two forces, it is very difficult to make
It's
a
very hard.
parallelogram.
Yeah.
You have to make many parallelograms, right?
Right.
Find resultant of 2, get to the third one, right? Or you have to make a polynomial instead of triangles.
Yeah.
Very difficult process. So what we could do, if we have multiple forces, resolve them into their x and y components,
Components.
just as we did, add them, find the resultant, you get the actual value, which is in terms of I and j. Then you can
Yeah.
find the magnitude and direction. In this case, we are saying 20.1 degrees from x-axis. Do you see that?
From the x-axis. Right.
X-axis. So this is how you could actually answer this particular question. Is this concept clear to you?
Yes, sir. Sir, I think this component method would also be it would be more accurate too, right? Because with cosine law, when I rounded, my angle was actually it wasn't exactly 20.1.
Yeah,
But
because
now I think we're more accurate.
yeah. So when you use sine law, because first
Yeah.
we found the angle 6.68, that was a rounded number. Therefore,
Right.
my solution, you must have noticed, I said 4 decimal places.
Four
So
decimal places.
when you use your law, in that case, find the angle first in 4 decimal places. Round
Yeah.
it and write down, that's okay. But in your calculation, you have to use 4 decimal places to get the real
Right.
answer. Otherwise, you'll make a mistake.
Okay. Yeah.
Very important criteria. Is this clear to you?
Yes, sir. Yeah.
Great. So we'll move on and take up another question. And this time, as I was saying, we have more or less a physics question, right? So the question here is, a 20 kg block lies on a smooth ramp that is inclined at 35 degrees. So we have a ramp now. And on this smooth ramp, we have a block. And this block is, we have a 20 kg block. And the angle of inclination is given to us as 35 degrees. The question is, what force parallel to the ramp, means like this,
Yeah.
what force parallel to the ramp will prevent the block from sliding?
Fall.
So tell me,
Yeah.
what force? We want to find what force. How will you do this?
Yes, sir. So we're given the mass of the box, right? And we know it's on a ramp. So first we can calculate its force of gravity, right? 20 times 9.8.
Yes.
And I think that'll come to 196. And now to find the x component of the force of gravity, right? Because that's what makes the box go down. We can break it
Because
down.
we are
Right?
applying a force parallel to the inclined plane, we are actually looking for this force effectively,
Yeah.
which is
Right.
acting along this direction, correct?
Right.
So now, what is this force? This force, as you learned, is mg sine theta, right?
Right, mg sine theta.
Where theta is 45, mg you have already found as 196. Is that clear?
Yeah,
And therefore, the force, which is not going to let this, or which will prevent sliding, we are assuming that mu is 0. Is it okay?
yeah,
Smooth surface. And therefore, we can now write down the answer as force as equals to mg sine theta, means we have 20, g is 9.8, and sine of 35 degrees, correct?
right.
So you can calculate this and tell me what is the answer you get.
138.6 newtons.
Is that clear to you? So that
Yes,
is
sir.
the force which will keep it from moving downwards, right? So how do? You basically resolve this into the x component, right? So this
Yeah.
angle is also 35 degrees, correct?
Correct.
Draw this normal here. And you see this force is parallel to this force. So it is opposite, right? Opposite
Right.
to this. So it's a sine component, right?
Right. Yeah.
And this normal is the cosine component here, which
Right.
is but you could resolve and see for yourself that this is mg sine theta, which acts downwards, and your force should be equal and opposite to this force to keep the object at the same position. Clear? Any questions?
Yes, sir. Clear.
Very good.
No, sir.
So now let's take up another question, and this time let's take. Okay, so we are taking a weight of 196 newtons is suspended from two ropes. So we have a weight of 196 newtons suspended by two ropes.
Yeah.
Which make an angle of 45 degrees and 60 degrees with ceiling.
Yeah.
Determine the tension in the shorter string. How will you do this?
Sir, we can draw like a triangle coming down from the roof, right? With the mass hanging.
Correct. So we have 45 and 60 degrees. Let's say 45 and let's say 60 degrees.
Yeah.
So this angle here is 45, 60 degrees, and that is a mass angle, 196 newtons.
Yeah.
We need to find these tension. Which one is the shorter string?
So it would be T2, right? Tension
It will
2.
be T2, right? Because in a triangle, smaller angle, smaller side opposite.
Smaller side.
Bigger angle, bigger side opposite. So it's
Opposite.
T2. So many things you have to understand the concept. Shorter string really means that it is against the shorter angle, right?
Correct. Yeah.
If you make accurate diagrams, more or less, you can see for
Yeah.
yourself which is the shorter, right? Now tell me,
Right.
how will you solve this?
So I think, like you said, it's very complicated to like make parallelogram sometimes, right? So I think we should deal with this in terms of components.
Okay, so
Resolve
one
each of the
solution.
X and Y.
Solution.
Yeah.
Number one, components. Correct. So if you resolve into components of all these three, and that means the system is in equilibrium, right? First thing.
Right.
System
Right.
is in equilibrium, right? So what you get is you have this T1 force acting at a 45 degrees angle, right?
Right.
If you think about horizontal, this case will be minus when it is on the other side, right?
Right. Yeah.
So, and 45. So T1 cos 45 is acting in this direction. And here we have T2 cos of 60 degrees, right? So if you do components, and we have no component horizontal with the vertical force, correct?
Correct.
So what you get here is two simultaneous equations. So one of them is that T1 cos of 45 degrees, which is acting left, should be equal to T2 cos of 60 degrees. Is that
60
right?
degrees. Right.
So you get a relation between T1 and T2, right? The
Correct.
other thing is the vertical component. So in that case, we have upward component is T1 sine of
Sine
45
45
degrees plus T2
plus
sine of 60 degrees
60.
is equal to
196.
196. Do you see that? So we
Yeah.
have two equations with two unknowns T1 and T2. We can definitely find them. Since we are interested in T2,
Yeah.
we can write what T1 is in terms of T2, right? T1 is
Right.
T2 cos
T2
60 over
cos
cos
60.
45. Once you substitute T1,
Yeah.
we are left with T2 and we can find the answer very easily, as you said, using this particular method. Is that clear to you?
Yes, sir.
Brilliant. But now my question is, part 1.
Yeah.
Make a vector diagram. Make we use force diagram, we say, but it's basically a vector
Yeah.
diagram. And then solve. Solve for T2. You get the idea.
Yeah.
If I specify, because I'm more interested in understanding the vectors part of it,
Yeah.
I'm saying, well, make a vector diagram and then solve this question. Now,
Yeah.
what will you do and how will you solve? Tell me now.
So I would probably still approach it with two vectors, right?
Yeah.
But now I'd make like a perpendicular line probably to
Okay.
indicate that the wall's there.
Okay. So let's try to understand how do we make a vector diagram. You know the system is at equilibrium, right?
Yeah.
Now, when a force is acting downwards and those two are pulling it upwards, we see one thing, that the whole system is in equilibrium. That means there is equal and opposite to this force, Newton's third law, which is acting on it, right? So we have equal and opposite force of 196 Newton, which is keeping this system at place in a way.
Right.
So we have this 196 Newtons going upwards. Now, I'm teaching you the steps to make this vector diagram now. And in the simplest possible way, you see how we are going to translate these forces into vector diagram and then find our answer. Very important part of vectors. Is it okay? So now, what you notice is this force is acting in that direction, and forces are not position oriented. They can be placed anywhere. I could move this line and draw a line parallel to this. Let me draw one. Parallel to this at like this. Do you see that?
Yeah.
Now, what is this angle with horizontal? It is 45 degrees, correct?
It's also 45. Yeah.
So we have this 45 degrees. Is that clear? So
yes,
let's say this is my force, which is this particular line, right? So which will make this angle as 45 degrees, correct? Do you see that?
correct.
And this is my tension T1. You get the idea?
Oh, okay. Yeah.
Now, the other line here is this line, right? So I'm going to draw this line from here, right? Do you see that?
T2. Yeah.
T2. And the angle made here will be?
60.
You see that?
Yeah.
So, and that is my 196, correct? So I have two sides, T1 and T2. The third is 196. I know that tension, right? That force.
Right.
And I know this angle, which is opposite to this, is 60 plus 45, 105 degrees, correct?
Oh, okay, so then you form a bigger triangle, right?
So if we have a triangle already, can I find T2 now?
Yes, sir, you can.
How?
Sir, if you resolve once again 45 into sine and then 60 into sine and then add them, will you end up in the same spot?
So let us see. First part, we have already drawn the vector diagram, correct?
Correct, yeah.
Second part, we have to solve this triangle. How to solve it? Use sine law. So T2 over this angle, which happens to be 45 degrees, correct? Big triangle. So T2 over sine of 45 degrees, which is 1 over square root 2, you know,
Yeah.
is equal to 196
196.
over sine of
105.
105. So T2 calculate is equals to 196 times sine 45 degrees divided by sine of 105 degrees. What do you get?
143.57. Oh,
Do you
okay.
see that? How
Yeah.
easily we have solved this example. This is actually more efficient method.
Yeah,
You
it is,
could
sir.
not- you did not even draw that. But definitely, again, here were two forces. You get the idea again?
Yeah.
We did this vector diagram. Normally, we do vector diagram with many forces, but with two, it is very simple.
Yeah. So actually what I was thinking is, once again, I was thinking to do like T1 cos 45 is equal to T2 cos 60, right?
Yeah,
And
yeah,
then
yeah.
since 196 is made up of both of the signs, right? And I was
Yes,
thinking
yes,
of
yes.
adding,
Yeah, yeah,
but
yeah.
that'll probably be longer.
That will be this process, right? Then
Yeah,
you're going
exactly.
back to your original process
Yeah.
of splitting it into X and Y components, right?
Right.
So that is one method, right? That's perfect. But when we have drawn the vector diagram, now we have a triangle. So you can solve the
Right.
triangle using sine law or cosine law, depending on the situation. So
Yeah.
you have a combination of opposite side and angle. Apply
Yeah.
sine law.
Yeah.
Got
Got it.
the idea? So
Yes, sir.
that is how we will be solving the force questions, especially when we're looking into tension in any string. Is that clear to you?
Yes, sir. Yeah.
So with that, we kind of have covered most of the type of questions which will be asked in this unit on forces.
Yes.
Last time we did cover about velocity. You get the idea?
Velocity.
And we
Yeah.
had seen last time how do we sketch a vector diagram for velocity, right?
Right.
So these vector diagrams for the vectors, which could be force or velocity or anything else for that matter,
Yeah.
are very, very important. You need to visualize and see how do we sketch them
Yeah.
and answer our questions, correct?
Correct.
So that is it. Now I'll give you another test question, which is related to what we have just done. So in this particular case, we knew both the angles with the ceiling and we solved it because we knew the forces. Now we'll give you the reverse thing. That is, we'll tell you the tension. We'll find the angle which the rope makes with the ceiling. We just reverse it. But so question for the test. So on a ceiling, that's the ceiling. What we are doing here is that we have two hooks given to us. And these hooks are 50 centimeters apart.
Yeah.
And the length of the strings is 30 and 40. And we have some body here whose weight is 30 into 9.8 newtons.
Yeah.
You have to find the angles. So that is the question.
Right.
So that is the question. You have to find the angles. So how will you solve this?
Yeah, sir. So I think we can draw a triangle again, right?
Yeah. So we have a triangle right there. And now you got these two sides, and you can now find what could be the angle.
So we can use cosine law, right? To find the middle angle.
Yeah. So for that matter, we can directly use cosine law to find any angle, right?
Right. Yeah.
So you can find angle alpha, or you can find angle beta, or any angle. Do you see that?
Okay, so we can directly jump to
Directly jump into in this
Yeah.
case. So that is the whole idea. So in such
Yeah.
questions, we can say what cos alpha is. So cos alpha is these two sides, which is 30 square plus 50 square minus 40 square.
Yeah.
Divided by 2 times 30 times 50. Is it okay?
Yeah. Sir, when you do cos inverse of 0.6, you get 53.13.
53.13 degrees. Correct. So that is how you can find alpha. Similarly, you can again apply and find beta. Is that okay?
Beta, yeah.
And that is how you could find the angles in this particular case. So when you're given, because you cannot measure, you can measure the lengths of the two ropes, correct?
Right.
So it's a very practical situation. Let's say in a garage, we are hooking up something, let's say car, right? So something,
Yeah.
and we're pulling it with the ropes. And we can always see, well, what is the length of each rope and what is the distance between the two. And in that case, we could solve such a question, correct?
Right. Yes.
Now,
Yeah,
once you do all this, you can find tension in the string also, right?
Right. Yeah.
So when you use tension in the string, then use the forces. Now we have got the angle. You get the idea? Now the
Yeah.
second part of this question will be find T1 and T2.
And T2.
So when you have to find T1 and T2, in that case, you have already calculated the angles.
Right. And then you
Then you find T1 and T2. So that becomes the test question. You get the idea. So you make twice the use of cosine law and then you use sine law.
Yeah. Yeah.
You get the idea of this question. This is a
Sir.
very
It makes
good
sense.
question from test point of view.
Yeah.
Okay. So we'll end up our lesson at this particular place where we have learned a combination of vectors today, basically scalar multiplication of vectors, and how do we resolve these and find the resultant, right? And what does it mean when a system is in equilibrium, when a system cannot be in equilibrium? What is the equilibrium force which is applied so that the system is in equilibrium? So that is equal and opposite to the resultant force. Is that clear? So with that, I think the whole chapter on application of vectors when considering forces is kind of complete, right?
Yeah.
So Akshat, any difficulty, any questions?
No, sir. It makes clear sense.
Very good. So can you summarize our learnings today?
Yes, sir. So we touched upon vectors as forces, right? And it reminded me of physics because we used to draw like force body diagrams to the vector arrows and everything. But now I think how we connected, like for example in that question I and J, right? It really relates to how we can solve it using vectors more than actual algebra.
Yes.
So I think that entire part is actually really good.
Perfect. And also you got good foundation on vector diagrams. In many situations, how do we sketch the vector diagrams and then solve the question? Perfect. Okay. So we'll end here. Have a nice day. See you next time.
Thank you, sir. Have a great day.
You too.